All right, so we had some questions on f of x equals e to the x versus f of x is the natural log of x. I'm referring to the graphs. Well, since e is about 2.718, okay, like all the magic numbers, it's an irrational number and it goes on forever. But we could say pretty much e is about 2.7. So maybe we should start by thinking of the graphs as 2.7 to the x versus the log with a base of 2.7. So these will still both be inverses. And they'll have the similar traits to the natural log and e to the x. And you know what, even better than that? Let's just start with 3 to the x. And ultimately we'll compare that to the log base 3 of x. Sorry. So here's a graph of y equals 3 to the x. And on Desmos, you can always make a table, which is an awesome feature. So I don't want a couple of those first y values to confuse you. So it starts with 3 to the negative 2 would be 1/9, and 3 to the negative 1 would be 1/3. So just take a good look at the graph. E to the x is going to be real similar to this. Also notice that these graphs all seem to go through the point 0, 1. Should make sense because anything to the 0 power is 1. Okay, next graph. Now we have y equals 3 to the x, y equals 2 to the x, and y equals e to the x all in the same graph. They look very similar, I hope you see. So since e is 2.7, the purple graph is sandwiched right in between the other two. So think of e to the x just like the other exponential functions. They're all going to look very similar. It's the transformations that are going to move them around. So this is the graph of the log base 3 of x. Now our original graph was 3 to the x, so this would be its inverse. Notice that the range and the domain have switched. What I mean by that is x has become y and y becomes x. So on the last graph I spoke about how, or earlier I spoke about how the exponential functions all seem to have 0, 1 as a point. Well, you'll see that a lot of our logs are going to have 1, 0. That should make sense because they're inverses. Okay, so let's try and tie it all together. We'll put the natural log and e to the x on the same graph. Here we go. So in general, your natural logs are going to look like the blue graph. Now this is in general, not special cases like fractions for bases. All right, so the blue graph goes through the point 1, 0, and it tends to hug the positive x-axis, and then it dives down the y-axis as x gets closer and closer to 0, but x never gets there. Now for e to the x, this is what a lot of the exponential functions look like. Generally, the red graph goes through the point 0, 1, like our exponentials do. And notice how this graph starts from the negative values of x. It never crosses through into the negative values of y. It hugs the negative x-axis, and then eventually starts growing the way we know exponentials do. So when it comes time to graph all of these, we need to have the picture of the parent function in our head, the general graph. And then from there, the transformations happen. So here you have it, e to the x and the natural log of x in general. And the next video, we'll break down the transformations on these graphs. We'll probably do them separately. All right, till then, see you later.